Okay, so let's finalise this week where we've been looking at subspaces. And what we're going to do now is we're going to take some of the concepts we've done and apply it to generalised least squares. Remember, the whole idea of generalised least squares is we don't have the variance structure, there's dependency, so we sort of adjust for that automatically. So what we're going to do now is, up until this point, we've been using, our distances and our angles and everything, just the standard inner product, which I've denoted here with the angle brackets. Remember, the dot product between two vectors is x1 transpose x2. And basically, you give it two vectors and it spits out a number, and we can use that to get angles and distances. And we're going to change it. We're going to have a new inner product. Again, this will take two vectors. It will renumber and return a number. I'll put a star here so you can see that it's a new one. And basically, it's exactly the same. It's x1 transpose and x2. But in the middle, we have this inverse matrix. Okay, so that's where we're adjusting. So we've got this distance, but the distance adjusts for the variance between our observations. So we're going to have this orthogonal projection, and now it's the same thing, but where before we had x transpose x to the minus 1 x transpose, we've put in these v minus 1s. This is still idempotent. It still gives us all the things we want. So we know that because of that, it's going to give our projection. To get our symmetry, we're just going to adapt it. We're just going to use the fact that it's not quite symmetric. We basically find that normally you would find that we have the symmetry, but we've got symmetry with the projection. Okay. Basically, if I take my y minus eta and I want to do the least squares, we find that py does that, and our L is now basically the column space of x. And also we find that our norm squared is basically x transpose vx. And so now I can take my p, which has got that v minus 1 in it, and that will return the something that lies in our vector. And the whole thing works. I mean, it was just a very quick sort of show. Basically, now the main difference is this L perp is all defined by its orthogonality with respect to the star inner product, not the other one. So there you are, just a very simple fact that once you get to this geometry space and these subspaces, things can become a lot easier, but very abstract. It doesn't change anything we do. We still do the same thing. It's still going to be in R the same. It's all the stuff, but I thought we'd just see the fundamental sort of objects underneath this at the end of this course. So that's it. All good. There won't be a next time. That was the last lecture. I hope you enjoyed it. That's about it. See you hopefully in data science. Bye now.